All right, here's a quick little video for this week's lesson on adding or subtracting rational expressions. So basically what a rational expression is just a fancy way of saying it is a function that has some sort of fraction in there. So for example, as you can tell, both of these expressions have both a numerator and a denominator. So just like if I'm adding or subtracting just regular fractions like 1/2 or 1/3 or 1/4, we have to first make sure we have common denominators. So this first practice example, not too difficult because if you look, our denominators are both the same, so we automatically are already starting with two common denominators. So when you do have a common denominator, all you have to do is add or subtract to the numerator. All right, so this final answer, I know my denominator is going to be a 3x because that's that common. And then I'm just looking now at my numerators here, and I'm going to just combine my like terms because I have an addition sign. All right, so I'm going to combine my x's, a 2x plus a 5x is a 7x. And then I'm going to combine my two constants, 1 plus 4 is a 5. All right, lastly, the thing that you would check is you would see if you can pull out a GCF and kind of reduce it. It's just like saying if you had like 2/4, you can pull out a 2 of each of these and you would get down to 1/2. You want to do the same thing over here. I can only pull a 3 out of the bottom, and then I can't pull a 3 out of a 7. So this is my final reduced answer. All right, so the hardest thing about this is getting common denominators. If my denominators are already common, I can just deal with the numerators. All right, we're going to look at two more examples in which we have to do a tiny bit more work. Let me grab a different color Sharpie here. Okay. All right, so if you look here, this is a subtraction problem, which is a tiny bit more difficult, so let's make sure we pay attention when we do this. And unfortunately, I do not have common denominators. I have an x plus 4, and I have an x squared minus 16. I can't really do anything to this x plus 4 to kind of simplify it down into its factors, so for the time being, I'm just going to keep it as an x plus 4. All right, over here on the right side, I can actually factor this denominator. This is a difference of two squares, right? I can take the square root of x squared, I can take the square root of 16, and I have a subtraction sign. So when you factor that, you actually get down to an x plus 4 and an x minus 4. All right, so still, I do not have common denominators, but this denominator is now much closer to this denominator. I just need to get an x minus 4 over here, and then I'll have common denominators. All right, the way that I'm going to do this is I'm going to multiply this left side by x minus 4 over top of x minus 4. When you multiply by x minus 4 over x minus 4, you're technically just multiplying by 1. So I'm really not changing the problem at all. And after I do that, I will have common denominators. All right, so I'm taking this piece right here, this 2 over x plus 4, and like I said, I'm multiplying it by x minus 4 over top of x minus 4. All right, I'm multiplying it by 1 in a sense. All right, when you're multiplying fractions, you just multiply straight across. So 2 times x minus 4 is just 2x minus 4. And then when I multiply these two binomials, I can just keep them in factored form. I don't have to go through and FOIL it. I can just leave it like that. All right, so now I'm dealing with this rational expression on my left-hand side, and I'm dealing with this rational expression on my right-hand side. If you notice, they have the exact same denominators. All right, so I'm gonna come over here, and I'm gonna just make sure I write it in the correct order. So this is going to be on my left-hand side, x plus 4, x minus 4, and it's a subtraction problem, and I'm subtracting x squared over x plus 4 and x minus 4. All right, common denominator is there, so I'm good. I'm going to write my denominator in right off the bat, x plus 4, x minus 4. All right, and then in my numerator, if you really wanted to, you could go ahead and distribute this. This gives me a 2x minus 8. So it's 2x minus 8 minus x squared. So now this is the tricky part, and we don't actually see it in this problem, so make sure you listen up to this. If there were two terms over here, so hypothetically speaking, if I had like an x squared plus 1, I would have to distribute this subtraction sign to both terms, and then I would just combine like terms. So this one I kind of get away with it not being as difficult because there's only one term. So once again, if you have a subtraction problem, you want to make sure you distribute that negative sign to every term in the numerator. This one's just a little bit easier because there's only one term. Okay, so now what I have, little sidebar over here, in my numerator I have 2x minus 8 minus x squared, right? Because I'm subtracting this x squared. I can't combine anything. I have an x term, I have a constant, and I have an x squared term. The only thing that I can really do is I want to rewrite this in standard form. That just means put the largest exponent first. So that negative x squared gets written first, and I have a positive 2x, and then I have a negative 8. This answer is a tiny bit sloppy just because we have something in standard form and then something in factored form. So like if you wanted to, you could go through and you could factor this if it's factorable and maybe cross off a term, but for the sake of this example, I'm just going to leave my final answer just like that, and I'm not going to reduce it. All right, last question here. We have another addition problem. Remember, addition is a little bit easier. You don't have to worry about distributing that subtraction sign. First thing, get common denominators. X plus 2 can't really do much with it, so I'm guessing I can do something over here to this quadratic in my denominator. All right, we have x plus 2, and then what two numbers multiply to get 4 but add to get 4? That is what, 2 and 2. So we have x plus 2 and we have x plus 2. All right, so now I can look to see what I need to add over here. It looks like I need to add one more x plus 2. So I'm going to multiply this right-hand side by x plus 2 over x plus 2. All right, the left side is not going to change. We get x plus 2 over x plus 2 times x plus 2. And then over here on the right-hand side, I want to have a 2x plus 2, and then x plus 2, x plus 2. Wow, there's a lot of x plus 2's going on here. All right, and then now I'm just going to add my terms together. All right, so I can go through and I'm gonna go ahead and distribute this. Once again, looks like I'm gonna put this in standard form. So this will be what, 2x plus 4. And then now I combine it with my like terms in my numerator. So I have a 2x and I have an x, so that's 3 x's. And then I have a 4 and a 2, which is a positive 6. And that's over x plus 2 and x plus 2. Let's see if we can simplify this numerator at all. Do you agree with me that I can pull out a 3 from both of these terms? If I do, I get this, right? Because if I were to redistribute this, I would get 3x plus 6, x plus 2, and x plus 2. And what we learned last week when we're simplifying rational expressions is if you have the same factor in both of the numerator and denominator, you can cross those off. So those x plus 2's will cancel out. So final answer is 3 over x plus 2. All right, check the solutions guide for the practice assignment for this week. It is posted on Google Classroom. And please email me if you have any further questions. Okay, bye.